Okay, continuing on with our probability unit. Today we are looking at ways to count outcomes without actually having to count them, because that can get kind of a lot, right? I mean, we looked at doing the experiments on our first day in probability. But there's got to be something simpler, right, than flipping that coin to figure out what's the probability of heads or tails. Well, we can do that using a tree diagram, and that determines the number of possible outcomes if you flip a coin twice. So here's the deal. On these decision trees, you've got a choice, and then you've got a choice to make after that. And that's what it's going to do, is give you a listing of all of your choices. Okay? So P of any event is the number of yes outcomes divided by the number of total outcomes. Okay? So let's have a look. The probability of the coin landing heads up both times. Flipped it twice, heads both times. Okay? So we've got the first toss. Okay? It can go heads or tails. So let's write coin toss here. It can go heads or it can go tails. That was our first toss. Which makes sense, right? Because it's a probability of 1 heads or tails out of 2 head-tails possibilities. Okay. Now that second toss is really where we get going. All right? So if I tossed heads up first, the second toss would also give me heads or tails. Okay? So if we think of these branches as the word or, that might make this a little more clear. But what if they came up tails on my first toss? Well, my second toss would still give me the option of heads or tails. Okay? And what we're going to do is we are going to start at the origin and follow that tree to the end. Okay? So we had 2 actions. We had our first toss, head-tail result. Second toss also had head-tail result. Okay? But this is the outcome layout of what happens. Tossed the coin, got a head. Tossed it again, got a head. In this case, I got 1 head, 2 head, and I wrote that down. Okay? Next branch. I tossed the coin, I got a head. Tossed the coin again, I got a tail. I got a head and a tail, and that's the part I wrote down. But this is a no event. Okay? I wanted heads up both times. 2 times is my yes event. Head and a tail, that counts as a no event. I should probably write this. This is the yes event. 2 heads. Okay? On the other path, if my first toss was a tail, then my second toss might have been a head, but that gives me a tail head, and again, this is a no event. Or, if I throw a tail the first time, the second toss would also give me the possibility of a tail. So that would give me tails twice. This is also a no event. Oops. Okay. So tossed it twice, done it. What I want as a yes event, heads up twice. I got heads up twice. No, no, no. But there are 1, 2, 3, 4 possible outcomes, and we want yes event divided by possible outcomes. I have 1 yes event. So the probability of getting heads up twice with 2 coin tosses is 1 over 4. And when I put that into my calculator, I get 0.25 or 25%. Okay? So we call this, without the decision tree, the fundamental counting principle. Okay? And that says that if an experiment has several parts, meaning stages or tosses, the first set of actions has some number, Mary, possible outcomes, and then the second activity has N as in Nancy, possible outcomes. If I flip that coin 3 more times, or a total of 3 times, then the third has P as in Paul, possible outcomes. Okay? And we could go from there and there and there. Okay? So what would that look like in this decision tree? I would have third toss. This yes event would split heads and tails. This no event, heads and tails. This no event, heads and tails. This no event, heads and tails. Okay? Well, I started off with 2 options for my first activity. It expanded to 4 options with my second activity. I now have 2, 4, 6, 8 possible outcome sets with my third toss. Okay? So every time I repeat an action, the expansion of the possibilities increases, or the number of possibilities expands. But you know what? This took a long time. I don't want to do it that way. I want a shortcut. This is the shortcut. Okay? We just multiply them together. All right? This is the possible outcomes for any experiment. And it has to do with the stages. Okay? I had 1 option, 2 option. From my first option, I had 1 option, 2 option. And here I had 1 option, 2 option. And in the end, I have 1, 2, 3, 4 total outcomes. So if I call this one a stage, it had 2 possibilities. And then this is another stage, and it has also 2 possibilities. 2 times 2 is 4. That gives me the total number of possible outcomes. Okay. And that, I think, is as far as I want to get on this one. So we're going to turn the page, and we are going to look at the page titled Combinations and Permutations. Okay? Or, how many ways can an event occur? And again, we start off with that fundamental counting principle. If event M, as in Mary, stage 1, and another independent event, stage 2, then we multiply them together, and that'll give us the total possible outcome number. And that's the denominator that we're looking for. Okay. So let's look at that again using that fundamental counting principle. How many ways can you roll an even number on a 6-sided dice? Even numbers 2, 4, and 6 and draw a heart from a deck of cards. Well, in a deck of cards, there are ace, king, queen, jack, and then 10 to 2. So if I count all of those up, I get 13 cards per shape. Hearts, diamonds, clubs, and spades. Suits. That's what we called them. Suits. And there are 4 suits in a deck. Okay. All right. So what have we got here? Okay. Stage 1. Roll dice. Okay. I have 3 yes options, and I have a total of 6 possible outcomes. And then the cards, I have 13 hearts out of a total of 52 cards in the deck. So this is my yes event, and this is my possible set. Okay. Okay, guys. So I'm going to lay this out in kind of a table form, and then let's look and see if we can do the really fast way of doing the math, okay? So what I'm going to do is I'm going to have a roll of the dice, and then the card suit option. So I'm going to roll a dice. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. And my card options would be a heart, a diamond, a club, and a spade. If I roll a 2, the card options don't change. If I roll a 3, same options. 4, 5, and 6. Okay. So let's look for our outcomes. If I roll a 1, I have 1, 2, 3, 4 options. If I roll a 2, I have 4 options. If I roll a 3, I have 4 options. If I roll a 4, a 5, or a 6, I still have 4 options. Okay? Because I can roll a 1 and draw a heart. I can roll a 1 and draw a diamond. I can roll 1 and draw a club. I can roll a 1 and draw a spade. So I have 4 outcomes possible. And when I total that up, 1, 2, 3, 4, 5, 6, I get a total of 24 outcomes. Okay? Well, my roll had 6 possible outcomes. My cards had 4 possible outcomes. And 6 times 4 is 24. So I was working really, really hard to get the same answer. So my fundamental counting principle says take the event, list out the number of outcomes, take the next event, list out its number of outcomes, multiply them together. Things get pretty simple. All right, so let's look at B. Okay. For Christmas, you want to get your parents a framed family picture. Okay? At the framing store, there are 4 different styles available in 5 different colors. So originally 4 times 5 would give me 20, but this problem goes on. So let's not make any judgments just yet. You decide to use a blue matte board, and there are 3 different shades of blue to choose from. Okay. How many different frames can I create? Okay, so there are 4 different styles. All right, I've got 4 styles. I've got 5 different colors of frame. And I have 3 blue matte boards. Okay? So I'm going to take these 4 styles times 5 times 3. I'm going to multiply these all together. I am going to get a total of 60 possible options. Okay. So you can imagine that if I had to make this decision tree, how big it would get. Oh my gosh. Okay. I could do it in a little table like this. Let's give that a try. So let's go with style. 1, 2, 3, 4 of those. Now let's go with the frame, color, and I have 5 frames, no matter which style I pick. And then I have the blue matte, and I have 3 options there. So if I pick style 1, I have 5 frame options, and in those 5 frames of this style, I can choose one of 3 blue mattes. That gives me a total of 15 options. Okay. If I pick style 2, I still have 5 frame colors in that style option. So I've got 5 frames and 3 blue matte options. That gives me another 15 options. If I pick, let me put number signs because I'm not telling you that you've got 3 style options. You have a total of 4. But number 3's style option still has 5 frames and 3 blue mattes. That gives me 15 options. Guess what? They're all 15 options. If I add those up, I get a total of 60 possible outcomes. That was a whole lot shorter. I think I like this one better. Okay? It's not that the idea of kind of working it out in a table or working it out on a tree diagram is wrong. But let's face it, this one was faster and easier to do. Okay? So think about that fundamental counting principle, and we'll probably go over some other examples in class.